We're surrounded by these incredibly complex systems every day, from the apps on our phones to the AI that's changing everything. But have you ever stopped to wonder, how do we make sure they actually do what we want them to do? Well, it turns out that the secret to talking to a super intelligent machine might just be the same secret to building a simple, sturdy chair. Let's dig in. It really all comes down to this one simple, powerful question. It feels like something the great physicist Richard Feynman would ask, right? How do you truly know that the thing you've created, whether it's a piece of software or just a simple request, is actually going to work the way you expect?
Okay, let's make this super simple. Imagine you've just finished building a wooden chair. It looks great, but is it safe? Will it hold you up? To be really, truly confident, you don't just stand back and admire it. No way. You have to test it. You sit on it. You wiggle around. Maybe you even kick it a little. You are actively trying to find its breaking point. That's the only way you can be sure.
All right, section 1, building and breaking software. So how does that idea of stress testing a chair apply to the digital world? Well, in software, a single weak leg doesn't just mean one person falls over. It could be a bug that affects millions of users. So developers can't just hope for the best. They need a solid blueprint for quality.
That blueprint has a name, the Software Development Lifecycle, or SDLC for short. Think of it as a roadmap that takes an idea from a simple plan all the way to a finished product that people are using. Now, every step here is important, but the one we're going to zero in on today is number 4, testing. This is the moment we try to break the digital chair. So, section 2 is the pyramid of confidence. How in the world do you test something as complex as a modern application? Well, you don't do it all at once. You build up your confidence layer by layer, starting from the ground up, in what's famously known as the testing pyramid. At the very bottom, we have the foundation, unit tests. This is where developers take the tiniest, most basic pieces of their code and test them in total isolation. It's the equivalent of taking a single leg of our chair and putting it in a vise to see exactly how much pressure it can take before it snaps. Okay, so once we're sure that each individual leg is rock solid, we move up the pyramid to integration testing. This is all about making sure the different parts play nicely together. Can we attach all 4 legs to the seat? Do the screws fit in the holes? Do all the pieces line up the way they're supposed to? And finally, at the very top of the pyramid, the final check, we have end-to-end testing. This is the ultimate test of confidence because it mimics a real person's experience from start to finish. This isn't about checking the parts anymore. This is about inviting a friend over for dinner and having them actually sit in the chair and use it for an entire evening. Does it work in the real world? Now, you can imagine that running these dinner party tests by hand every single time would be incredibly slow. That's where automation tools come in, little programs that pretend to be a user. 2 of the big players are Cypress and Selenium. You can think of Cypress as the newer, sleeker tool that's really easy to get going with for modern web apps. Selenium is the old, powerful workhorse. It's a bit more complex to set up, but it works with almost any language or browser you can think of. Okay, section 3, talking to the machine. So far, all of this testing has been about making sure the thing we built was built correctly. But what if the whole game changes? What if, instead of building it ourselves, the process starts with us asking a machine to build it for us? That's a totally different ballgame. Just picture this for a second. You're no longer the carpenter. Your job is to give instructions to a robot that is unbelievably smart, but also unbelievably literal. It has absolutely no common sense. It will do exactly what you tell it to do, for better or for worse. So how do you make sure it builds the right chair? I mean, what do you think would happen if you just told that robot, make this chair better? You have no idea what you'd get back, right? It might add a 5th leg, it might paint it bright pink, it might decide the best chair is actually a lamp. The instruction is vague, it's ambiguous, and it forces the robot to guess. And when a literal machine guesses, you're going to get some weird results. And that brings us to section 4, a framework for clarity. See, to get the right result from this robot, we need a different kind of blueprint, not for testing the final chair, but for crafting the perfect initial instruction. We need a framework that guarantees clarity. This is what we call the art of the ask. This whole framework really stands on 3 simple pillars, the 3 C's. First, be concise. Just get straight to the point, no fluff. Second, be clear. Use precise language and leave no room for misinterpretation.
And finally, be consistent. If you call something a customer, don't switch to calling it a user halfway through. You'll just confuse the machine.
So if you put those principles into practice, you can build a simple but really powerful framework for your prompts. You don't just ask a question, you give it a persona to act as, you define the specific task you want it to do, you provide all the necessary context, and you tell it the exact format for the answer. Suddenly, your request is a complete, unambiguous blueprint.
Let's look at a quick before and after. Here's a typical, pretty vague prompt. Identify common factors that influence the restaurant industry. It's not wrong, but it's so wide open. It's basically an invitation for the AI to give you a generic, rambling essay that might not be what you want at all. Now, check out the difference here. We gave it a persona, acting as a restaurant marketing expert, a clear task and format, create a bulleted list, and some really important context. We're interested in the fast casual part of the industry. By getting rid of all that ambiguity, we've basically guaranteed a much, much better answer. So this brings us to our final section, the universal skill. We've just explored two worlds that seem completely different, right? You've got the super rigid discipline of software testing, and then you have the creative art of asking an AI questions. But what if they're actually two sides of the very same coin? And this is really the core idea of this whole explainer. A good software test is meticulously designed to eliminate any ambiguity to confirm a specific, predictable result. And a good prompt, it does the exact same thing. Both of them are about achieving crystal clear, precise communication with systems that do exactly what you tell them to do. And this is why this should matter to you. No matter what your job is, this ability to think with structure, to communicate with absolute clarity, and to methodically stamp out ambiguity, that is becoming a fundamental skill for thriving in a world that is being built and run by these complex systems. Which really just leaves us with one final thought to ponder. As these incredible systems get more and more powerful, maybe our most important job will shift from trying to have all the answers ourselves to simply being exceptionally good at asking the right questions. Thanks for watching.